Hi everyone, let's take a look at the problems of the Biweekly Contest 122. If you like my explanations, please like and subscribe, and also introduce my channel to your friends who are practicing as well. Thank you. The first problem of the contest is easy as usual, and it says divide an array into subarrays with minimum cost. And we have an integer array of length n, and it defines the cost of an array is the value of the first element. The cost of an array is the value of the first element. So the cost of this array is 1, and the cost of this array is 3. We need to divide nums into 3 disjoint contiguous subarrays, 3 disjoint. And we want to return the minimum possible sum of the cost of these subarrays. The first example, you can see that the answer is 6, because 1, we should take that. That is the first subarray. We should always take the first number. And from the rest of the array, we take this 2, which is another subarray, and we take this 3, 12. And the sum of 1 to 3 is going to be 6. This one has only 3 numbers, so the answer is 12. And this one, we should definitely take 10. And from the rest of the array, we should take 2 of them, and we take 1 and 1. The input length is at least 3, because we have to take 3 numbers, meaning 3 subarrays. The n is very small, but let's go and see what's the observation. The observation is kind of simple. So we have an array, and we want to take 3 cuts, like 1, 2, 3, and we should take these 3 minimums, these 3 numbers, and the sum of them should be minimum. So about the first number, we know that we should take that. We should take that, because if we don't take that, there's no first subarray. So we should take that. And from the rest of the array, it doesn't matter which 2 numbers we take, because wherever we take from this number up to that number is going to be the first subarray. From the second number to the third number is going to be the first subarray and the second subarray. And from the third number until the end of the array is going to be the third subarray. So we take the 2 minimums. We take the first one, plus min 1 and plus min 2, considering the rest of the array. So we only consider the rest of the array other than the first number, and we take minimum 1 and minimum 2. That is the observation. Okay, let's write the code. To find the next 2 minimums of the array, we can do a lot. We can do it in different ways, you know. And then the easiest one is just to sort the rest of the array and take the next 2 numbers. So it's going to be sort nums.begin plus 1 and nums.end. And the answer is going to be return nums 0 plus nums 1 plus nums 2. That's it. We can do better than sorting, but it's not necessary here. So 6, 12, 12, submit, and accept it. Let me tell you about 2 variations of this problem. So the first variation is going to be in how many ways can you have 3 disjoint contiguous subarrays with the minimum possible sum? Okay, so for example, if you have an array like this, like 10, 10, 5, 2, 2, 2, 9, 8, 2, 9, 9. In how many ways can you have 3 of them? So we know the first one we should take. So, and from the other 4 2s, you can take any 2 of them. So in this case, it's going to be combination of 2 and 4. So any 2 of these 2, let me make this 3. So any 2 of these 3s, if you take, it's going to be the minimum. So it's going to be the combination of 2 and 4, or 4 and 2. Yeah. So the first variation was this. In how many ways can you divide the array into 3 contiguous subarrays with minimum possible sum? This is the first answer for the first question. The second one is also easy. What if let's go back to the question. So what if instead of 3, you have to make k disjoint contiguous subarrays. So here, sorry, instead of 3, it's going to be k. What's the answer to this? Think about it, and if you can come up with one variation of your own, please let me know in the comments. Thank you. See you in the next problem.